All right, here we go. Intro to derivatives. So this is going to be a couple of different videos here. The first one, we're going to go over derivatives from first principles, and I'm going to teach you about the equation that we can use to get a derivative from first principles. Now, first, I guess we should talk about what in the heck do we mean when we say derivative. All right, well, a derivative, if you have a function, let's just take a simple quadratic function right here. All right, so the derivative tells you the slope of the tangent at a point. Okay, now if you get a derivative function, it'll actually tell you the derivative anywhere. You just have to then later put in which point you want. But we'll also be finding the derivative at specific positions on the line. So the way that we do this, and we kind of had a video, there's another video about this using the secant method with x and a. This one's going to be very similar to that. What we're going to do is we're going to pick a random point on the graph. Okay, now this random point has an x value. Yes, it does. That x value is x. Okay, it doesn't matter where it is, the x value will always be x. Now, in this equation, I put x into some type of function, and that function does something to x and ends up giving me the y value. So the y value here is f of x. And so essentially this point right here has a value. It's x, comma, f of x. Everybody okay with that so far? Hope you said yes, because there's no way for me to answer your questions right now. So we'll just go with this. So from here, we are now going to choose a second point. Okay, so we're going to choose a second point. Now this second point is at a different x value. Now it doesn't matter if it's to the right or to the left, but the distance away in the x direction horizontally is h. Sorry. So this is now at x plus h, because here was x and it's h more away, so it's at x plus h. Okay, well, if the x value is x plus h, I take that value of x plus h and I put it into the function and I work it out. And what do I get for the y value? Well, I get f of whatever x plus h was. And so I got a y value. So now I have a second point, which is x plus h, comma, f of x plus h. All right, now I have 2 points. Now we talked about, so now what we're trying to do, remember, is we're trying to find the slope of the tangent at this point right here. So we're trying to find the slope, essentially, of this line right here. Now, the slope between these two is pretty close to that. And if I bring the point in closer and closer and closer, the slope should be getting better and better and better, even closer to this green line. So if I can take this red point and bring it in so that it is infinitely close to x, then the change from that point to the next one should be almost exactly the same as whatever the slope of this tangent line is. And so that's what we're going to do. We're going to bring this red point in as close as we can. Well, how do we do that? Well, we make h really, really small. So first, let's write an equation for the slope from the black point to the red point. So what we're going to do is we're going to just write out f of x plus h. So this is y2 minus y1 over x2 minus x1. So f of x plus h minus y1, which was f of x, all over x2, which was x plus h, minus x1. And we simplify that and we get that the slope of this secant is f of x plus h minus f of x all over, now the two x's are going to cancel out, leaving me with just h. Now, to do what we were talking about before, to bring this red point as close as we can possibly get, we want to find the limit as h. Now remember, h is the distance from this point to that point horizontally, the distance between those x values. I want that as small as possible, so I want h to become as close to 0 as I can get. Now remember, that's what a limit is. The limit is how close can you get to that point, right? What is the value as you get closer and closer and closer? Somebody mentioned in class, well, a single point can't have a slope. Well, you're right, but the limit of those as we get closer and closer to 0 does actually have a value, and that's what we're looking for. So the limit as h approaches 0 of this function is then the derivative function. And so what I'll do in the next videos is I'll go through a couple of examples and show you how to use that. All right, so video number 1 done. You now have your introduction to derivatives.